Start the recording, just it'll be on the laptop. Okay. So welcome to the guys at home watching the recording. So far we've kind of just gone through the first question 21 of the AMC 2018. So for this one, just have to do a bit of estimation. I just realized that maybe a month was around 30 days. So you just have to multiply the fraction by 30. And you see that you don't have to be very exact in your answer, and you should get the right one. All right, and then for 22, so far we hadn't looked at, we can guess and check this question, but we still probably want something more useful to start off with, right? And if you notice that adding the 4 triangles together, you count all the outside circles once, and you count all the inside circles twice. But you actually know what that adds up to, because it adds up to 36 plus 20, because just counting all the squares once, and then you're counting the inside again. But you know the inside adds up to 20. Okay. So far we know that the triangle sum is 14. Okay. All right. So I reckon now it's time to do a little bit of guess and check. So first of all, we know that the center square adds up to 20, so I might just well start off guess and check. So maybe 4 and 7, and then 5 and 6. Yeah, so you can guess kind of lots of stuff. 8 and 1 and 2. Oh, okay. So I think that was what I initially guessed, and yeah, if I just went over a little bit, I would have skipped this workout entirely. But as I said, this is still requires a little bit of luck to just get this one, and a little bit of intuition. So for these types of questions, when you want to add up to something, you probably just want to go with the middle numbers first, okay, and fill those out first. So yeah, I was still a little bit lucky, but this triangle sum of 14 definitely helps you a lot, because instead of guessing and checking randomly, you can just now cycle through all the numbers. So you can go, oh, 6, and you know this has to be a 5, for example, right? So it gives you a lot more flexibility. Okay, but yeah, all in all, we know that x plus y is just going to be 13. Okay. All right, give you guys a few moments to finish off your notes, and we'll move on. Okay. Next question. Another counting question. They ask us, how many ways can you tile this very long hexagon using just these rhombuses here? Okay, so out of you 3, did any of you get an answer for this one? So you can, if you don't mind, type it in chat, please. I think you can direct message me if you want. How about Alan? Did you get one Did you get an answer for this one? Yep. Great work. Yep. Well done. So I think, did you perhaps guess and check this, or was there something else you noticed? I think both methods work pretty well. Yeah. So the way to think about it is something like this. You might just start, guessing and checking some random ones. I know, like, I'm just drawing strokes, but this just means that we're using this rhombus. Okay, it just kind of makes it a little bit easier to visualize rather than spending a lot of time drawing, lines. Yeah. So different orientations of rhombuses. Good idea, Alan. Yeah, so you might start guessing, checking a few, and yeah, you notice that there's only one rhombus that is, pointed vertically like this. The rest are like slanted, right? And yes, there's only going to be one that works. Reason is because of this. Once you have your one vertical rhombus, you see that everything else is like forced. For example, this triangle has nowhere to go. It kind of has to join in with the next triangle like this. Same thing for the bottom one. It also has to join like this. And as you see, the rest of the diagram is completely forced. Yeah, you can only do it one way. So all we have to do is count how many vertical rhombuses I can have, right, in the picture. Okay. So there can only be one vertical rhombus. All right, and all you have to do is count how many there are. There's like one here, one here, one here, one here, one here, one here. Okay, so there's going to be 6, and that's how you count it. Yep, great work, Alan. Very well explained. All right, moving on. Next one here, a little bit of a tricky one again. So let's have a look at it. So the way to do this question is definitely not to just guess and check without, any thinking involved, okay? Because just like, the question we did before here, it does help if you first do a few steps to, make the question a bit simpler. And the way to make the question a bit simpler is just, clear the denominators first. So have it all under one denominator so that, you can pretty easily add and subtract the numerators rather than, having to do the fraction every single time. So we can probably just multiply the denominators together, or you can take the LCM, like whichever works for you. But we'll take the LCM because luckily this is quite easy to find for now. Okay. LCM of 3, 4, 5, 6, 7. So first of all, you can cross out the 3 because the 6 already fits with the LCM. All right, and then this one, you go 4 times 5 times 6 times 7. But just divide 2 because there's a factor of 2 in these two numbers. Like, yeah, if you remember, this is kind of the pattern, right? Like, for example, LCM of 4 and 6 is just 12. Yeah. Okay. So it's 12 times 5 times 7, which is 420. Okay. So we're getting some progress. let's just write every number in terms of 420 now. If you're not comfortable, just divide. Yeah, just go 420 divide 4, for example. Okay, so pretty good now, right? Because all we have to do is put an add or a subtract symbol in front of each of these numbers. And our goal is to get the smallest possible number. So as close to 0 as possible. Okay. It doesn't matter if you go negative, like -2, for example, because you can just flip the minus and plus for every single number and you get like back to 2, for example. So yeah, as long as you get as close to 0 as possible, that's the goal. Okay. Yeah. Okay. So this is where you start to guess and check. So from here, if you guys got to this step, which combination of plus and minuses gave you the best result? Does anybody want to volunteer for this question? Hey, Kingsley, did you get anything for this one? That's okay. Okay. So yeah, kind of the key thing to think about is, yeah, as I said, it doesn't really matter whether you put a plus or a minus in front of the first number, for example, because what you do is you can just flip all the symbols if it turns out to be a negative answer. So yeah, I mean, let's just make it a plus. Okay. So the most important thing here is now we want a number as close to 0 as possible. What does that mean? Well, I have plus 140. So, it's pretty much not good to go all negatives because your number will be very, very, very small. So it definitely won't be the best. So yeah, it's probably the best idea is to have 2 positive numbers and 3 negative numbers. That should give us the most optimal result. Of course, having 3 positives and 2 negatives is still not as good because you already have 140 as your positive, right? And that's like the biggest number. So you probably only need 1 extra plus because that's kind of the reasoning involved. So we figured out that there's 2 positive numbers and 3 minuses. Okay, so now which one should be our plus and which one should be our minus? We can just guess and check this one now. Okay, so let's just go with the 2 biggest numbers being plus. So it's like plus 245 and minus 214. Okay, so not bad. We get like 31. But did any of you get any better than 31? What if you put the plus in a different location? So have a go now. Try putting the plus in 84 and then maybe add 70 as well and see if you can get a better result. And we can finish the question off from there. Okay, give you a few minutes to continue. Okay, yep. Isabella got it. So what about the other 2? Just a few more seconds to think about it. Anybody else got an answer? Yeah, so well done, Isabella. Um, this one will give you the best ones where you just put the positive next to the 84. Okay. And minus, minus, minus. So yeah, this will give you plus 224 minus 235. So yeah, it is minus 11, but again, don't worry because you just flip all the signs around and that will give you the smallest result. So basically 11 over 420. Yeah, well done. Okay, so 11 over 420. All we need now is to figure out which option it belongs to. So just pretty much quickly check through it. 1/100, definitely much bigger than that because 1/100 is like 4.2 over 420. And by the same reasoning, it is also going to be bigger than 1/50 because 1/50 is like 8.4. So still bigger. But it will be smaller than 1/20 because it's more like 21, for example. Okay. So it is in between 1/50 and 1/20. Okay. Well done, guys. I'll move on to 25 next. Please make sure to finish your notes. Cool. Okay, so this question here is a subtraction, but with lots of digits. So what do we do? So yeah, usually when you do subtraction without a calculator, you just have to, you never look at it like this and go, know the answer straight away. You just have to put it in kind of the vertical form. Minus 2, 2, 2, 2, 2. Okay, so it's important. Remember, in subtraction, we always have to line up the digits, right? From right to left. And to do a division like this, okay, there's definitely going to be a lot of repeats in the middle. So in the repeats in the middle, it's okay to just put dot, 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 because it's the same digit and you can pretty much get it from these digits here. But it is very important to leave a few digits, for when the 2 stops, because let's just say this is the 50th digit and then the 1 just keeps going. Okay, this is where the digits can change and you need to be very careful. Okay, so as you can see here, I put 2 digits and 2 digits here on either side just to make sure you get everything. You might even want to put an extra one here, but we'll see how we go. Okay, there'll be a same thing, 2, 2, 2, 2. So basically, this is your first 50 digits. And This is the rest of the 50 digits. All right. So just wondering what answer you guys got. Or maybe if you didn't quite finish this question, I'll now just give you a minute or two to have to think about what you might do in this situation. Okay? All right, just give you guys a few minutes to have a think about it. Start the subtraction and see if you can find the pattern. Okay, the pattern is the most important thing. So I'll start you off the first two digits. For example, you have a 9 here, and then the 0 carry, so it'll be 8. And then what goes on from there? Okay, hopefully you've done the subtraction now. You might not really still be unsure of how to add digits up, but hopefully you complete the subtraction now. So yes, from here it will stay with 8 because there will always be like a carry down. So like the digit above here will always go down to 0, and then it will be like 10 minus 2 is 8, and it will take the 1 from the next digit. Okay. All right, 8. This one here, be careful, still be an 8. All right, but it took the digit from here, so this will now be a 0. Okay, now what about the rest? Rest is all good. Rest will all just be ones. Okay. Okay, so the question is, how many ones did you get? How many 8s did you get? And how many 9s did you get? And then from there, you need to calculate the digit sum. All right. Please pop your answers in chat now. I want to see which results you get. Oh, yeah, so Kingsley, I'll just check if it was on the iPad. Yeah, sorry, Kingsley. You have to. Oh yeah, thanks. I see lots of answers there. Yeah, you just have to send it to the Edwin sheet, the one with the logo. I don't check the messages on the iPad because I'm sharing the screen. Yeah. But thanks, Kingsley. I see your answer as well. Yep. Well done, Alan. Yep. So your answer is 450. Okay. So you have 49 ones, 49 8s, and 1 9. Plus a single 9. So just a quick way to do it without having to do multiplication is you can grab the 49 and it'll add up to 49 times 9 plus 9, and this will be 50 times 9. Doesn't save you too much time, but I guess this is a neat trick. All right. Please take a screenshot of this one and we'll move on now to the last 5 questions. Cool. Okay, the first one here, interesting question. So it says I can only use the digits 0, 1, and 2, and has to have different numbers on each face. And numbers on each pair of opposite faces add to the same 3-digit total. Okay, so that's an interesting property. What is the largest that this total could be? Okay, so for this question, we have to first think about how we might write the numbers, right? Because it should make it easier for us to visualize it. The way you probably want to write this one is just write out the 3 numbers, and ideally, yeah, you're just adding it to the opposite faces and we're getting the same result each time. Okay, so that's kind of a nice, neat way of running it. So, like, for example, if I know that this was a 2, for example, then this is a 4, and I know that the rest is 4. Okay, so very good way of writing it out. Okay, so we kind of have 3 options. I guess we can choose either digit. We'll just choose the first digit to start off with now. We'll look at this one. Okay, so I can only use digits 0, 1, and 2. Can somebody tell me which digit should I be getting in this result here? So there should be a digit here. It should either be like a 2 or 3 or 4. Can't get any bigger than a 4, but yeah. Which digit should the first one be? So yeah, it can't be a 4 because, well, you'll need a 3 here. You don't have to worry about carries because the most you'll get is like 2 plus 2, right? So no carries needed. Yes, so that does mean that you can only have a 3. So you do have to look at the smallest digit and when you add a 2, okay, then this is a 3, and that's the maximum it can be. Okay. So yeah, and then this will be a 1, 3, 1, 3. Cool. All right, so second digit, let's have a look at that. Okay, so there's a 0 here, so we have to look at the 0 first, because even if this was like, a 3, the 0 wouldn't be able to keep up. Okay, so we have 2 digits so far. Last one. Okay, so let's have a look at 0 again. We could have 2, 1, 1, 2, 2, 2. So is this our answer? 3, 2, 2? What do you guys think? 322. Does that work or not? As in, everything seems to be all good, right? Just have to read this important thing. Different number. You have to have a different number for each face. And as you can see, the 201 repeats here, right? So this number here and this number here. These two numbers. So unfortunate. That does mean we have to lower our guess a little bit. So this is why when you lower your number, you have to just lower the unit digit. Okay, you don't need to lower the hundred digit because that's just unnecessary. You want the largest number. So sorry, you want the largest number. So we might as well just subtract one rather than subtract 100, right? Okay, so we're going to go down by one digit. You're just go down to 1, 0, 0. Okay. Yep, everything checks out. All the numbers are different. And your answer is 321. That's the biggest your total can have. Yep, cool question. So just, yeah, make sure, for example, it can't be anything in the 400s because, again, this one, you would have to add to a 3 to get a 4. And you can't use a 3 as your digit. Okay? Cool, let's move on. Okay, so this next question here definitely seems like a guess and check question, okay? But let's have a look at it because there's quite a lot going on. So I have a 3-digit number and I added digit to create digit sum. Okay, so digit sum of a number. And when you go number minus digit sum, so let's write that down in simple terms. So it's easy to see. So number minus digit sum equals to number squared. Okay, so I might as well just say my number is n. Okay, so number n. And I mean, I mean, you could say digit sum is D. I choose probably not to, but yeah, you can have digit sum as D, but I'll choose not to. Okay, so n minus. Okay, maybe digit sums used quite a lot, so maybe I won't. Maybe I will just have, yeah, digit sum as D. Okay. All right, so number minus D equals to D squared. That's what the question's saying, right? So because they're saying it's subtracted from my number, you have to go number minus D. Okay, just a bit of terminology. And the result is the square of digit sum, so D squared. Okay, so we can guess and check from that because technically, even for any D, like if you guess and check a random digit sum, you should be able to get a number. And then what you can do is you guess and check that number, look at it. For example, let's go with digit sum is like, I don't know, 8. You have 8 squared minus 8 number. Okay, so first of all, yep, let's put D to the other side. Makes sense. Okay, so for example, if D is 8, your number is 8 squared plus 8, or if you like multiplication better, it's 8 times 9, so 72. And then what you do is you check this number. Is the digit sum 8? Well, no, the digit sum is 9. And of course, it's not even a 3-digit number, so it won't work. Okay, so if you guys didn't quite get the question during your own... Okay, I see Isabella got it. Well done. But How about the other two of you? You can try this one now. See if you can get the answer. So you probably want D to be at least 10 because that's the first one that will give you a 3-digit number. So for example, D is 10. This will go 110. But here the digit sum is 2, so it doesn't work. Yeah. That's just an example. And just keep going up. Yep. Well done, Kingsley. Got it as well. Okay, reckon just give you 10 more seconds and then we'll go through it. Yeah. So good. The answer is 156. That is your number. Yeah, so you just have to be as quick as possible because worst case scenario, you have to guess up to like 30 times 31. Anything after that will be too big. But yeah, that's still quite a lot to guess in check. But luckily, the answer is quite small, so you don't have to do too much. So yeah, so for example, 10 times 11 is 110. And your digit sum is 2, so doesn't work. What about 11 times 12? 132. Your digit sum is 6, doesn't work. 12 times 13. Your number is 156. And digit sum is 12. So all good. You got your answer on the third go. Okay. 156. So yeah, as you can see here, once you write it in a very nice form, you'll be able to guess and check it. So it does involve, for example, taking the minus D and putting it to the other side. Okay. It's a lot harder to keep the D here because, yeah, you're just doing something like this. Number minus 12 equals to 12 squared. I mean, yeah, you could just do it pretty easily, but it's a lot easier to just look at it like that, right? Okay, cool. So make sure to get everything down and we'll move on to the next one. Okay, so next one. Okay, so for counting questions, remember for these types of classic ones where it seems like you're just, taking cases and guessing and checking, the two strategies that I talked about, where you have to try to see if there's any symmetry involved, and then you want to be systematic. So like systematic just means you be very orderly. So whether that means going from highest to lowest, there's lots of strategies. You can take a tree graph, lots of different ways. But yeah, let's first have a look at the symmetry, because that kind of stuff is very important to help you simplify the question. Okay, well, right now it doesn't seem like there's anything useful, right? For example, it would be convenient if all the road signs were just 3-digit numbers, but is it that convenient? Like, can I just say 0000999? And does that work? Well, yes, it does, right? It does work. The reason why is this. Notice that because our road is 999 kilometers long, that means that there's no carries. There's no carries when you subtract 99 minus any number, like 271. It's just going to go 728. So that literally means that these numbers kind of pair up. If you have a 1 on one side, you have to have an 8 on the other. If you have a 2 on one side, you have to have a 7 on the other. Okay? So they kind of form these pairs. So the 0 and 9 form a pair. 1 and 8 form a pair. 2 and 7 form a pair. 3, 6 form a pair. And 4, 5 form a pair. Okay? So yes, that doesn't mean that it's okay just to leave everything as 3-digit numbers, even like 072, because the point is you might be asking, well, that means I'm having an extra digit, right? Having an extra different digit, but it doesn't even matter, because when they're saying exactly 2 different digits, to start off with, for example, this would be 926. Even if you didn't have the 0, you'd have 5 different digits. So as you can see, it's going to be kind of odd, right? The point is you won't be able to have exactly 2 digits. Like, for example, this case, that would work, like 909, and this would be just 9, right? 90. The only case that you're going to have 2 different digits for this is when you have something like this. But it doesn't even matter if you put the 3rd digit anyways, because it's guaranteed that you have to have a 0 there, okay? So hopefully that makes sense. I know it's a little bit hard to explain. Sorry, to understand this, but yeah. What I'm basically saying is it's okay to have the first digit being a 0, just so that every road sign has exactly 6 digits, okay? All right, but yeah, that was probably a bit too long of an explanation. Let's get down to the detail of the question. So we still have to look at the symmetry. What symmetry is there? So maybe I'll ask you guys, what symmetry did you think exists in this question? Yeah, what is the symmetry? So I think you might be thinking the symmetry looks like this. It actually doesn't matter which 2 digits I use. So for example, if there was a road sign that was, 272 and 727, so like something like that, that would work. Well, first of all, it should not matter what first digit I have. So if my first digit was a 3, I should still be able to figure out something that works just as well. So for example, 636 and 636. Basically, I just swap all the 2s with 3s and all the 7s to 6s. Yeah? So that's the symmetry. it does not matter what the first digit is. So my first digit can be anything. Just for the sake of convenience, let's just go with 1. Okay. So what that means is in your road sign, once you figured out everything that starts with a 1, so like for example, 199,911 and just go, sorry, I meant 188,811. Or actually maybe let's go with 2, just so that the thing in the middle doesn't confuse. So 277,772, for example. So once you figure out all the road signs that start with a 2, all you have to do at the end of your question is multiply by 10, because the same number of signs will start with a 1, a 0, a 2, all the way up to a 9. Okay? So yeah, you can see that for these types of questions, there should always be symmetry involved. Because yeah, otherwise, if you don't notice it, it is very hard to get the right answer. All right. So I'll pass it over to you guys now. How many road signs did you find where the first digit was a 2? Okay, give you a bit of a time to try it out. Somebody said 19. I'm not sure. That is a very big. That's a lot of road signs. There should not be that many. Yeah. There shouldn't be too many because, yeah, if the first digit was a 2, that literally means that your only road signs are going to have the digit 2 and 7, because the 7 goes in the first digit of the second sign. Yeah. So yeah, you're pretty much only going to be restricted to having digits of 2 and 7. And as you can see, there's really not too much variety you can have. Yeah. Something like this. There's really only going to be these 4 road signs. Okay. And yes, if you're observant, notice that you could just go 2 times 2, because there's 2 ways to get the second digit. It's either 2 or 7. There's 2 ways of getting the third digit, either 2 or 7. And once you kind of have the first road sign, the other side of the road sign has to be, 999 minus that one. So there should only be one answer. Okay. So your total answer is 40 ways. Yeah. All right. I know you guys are due for your break. So it's already 7:35. So I'll give you guys maybe until 7:42. Give you a bit longer than 5 minutes to have a rest. Okay. So when you get back, we'll finish off the AMC, just 2 more questions left. And then we'll move on to some more topics. We'll be going through pigeonhole principle, but yeah, that's for later on in the lesson. Okay, enjoy your break, guys. welcome back, guys. Let's move on to 29. Okay, so for this question here, another looks like seemingly guessing check, right? You just have to basically guessing check, either X, Y, and Z. There is, a good choice and a bad choice, as there usually is. So you do have to think about which one you have a look at. But I'll also maybe just quickly talk about another way that would also work. Maybe if you've seen some of these, the visibility stuff before, the visibility rules. So this one will be a divisibility by 18. Yeah, Z, X, Y, Y has to be divisible by 18. Divisible by 18, you basically break it up into divisible by 2 and divisible by 9. Okay. So stuff like that means, for example, Y here has to be even, or Y always has to be even, right? Because multiplying by 8. And also, more importantly, the digit sum of Z, X, Y, Y is also divisible by 9. Okay, so that's what you get. We're not going to use that this time, just in case you didn't really see it. But just notice that in the future, you can use whatever the number is here. Okay, you can use those divisibility rules to help you as well. Okay, but for this question, we're just going to do guessing check. Okay, so the question is, which to guessing check first? Should we go with X, Y, or Z? Any thoughts, maybe? Which one would you guess and check? X, Y, and Z? Yep. Well done, Isabella. You got the right answer. But I guess, did you guess and check using X, Y, or Z? Like, if I just started from, 0 and went up, not 0, but if I just started from 1 and went up to 9, which digit would you choose to do the guessing check with? Yep, well done. Z, Isabella, well done. Yep, because this will also give you Y for free because you just multiply it. And yeah, you just go with any other digit and it's not as good. So for example, Y, if I just let this be like a 2, sure, Z will be like, I don't know, 4 or 9, but it's just not as clean, right? And if you start with X, well, that's even worse, right? You don't get anything. Yep, so we're going to guess and check with Z. So let's start guessing checking. So let's start with Z equals to 1. I know this will be, very tedious. So just try to do this as fast as you can, okay? 8. Okay, so I know Y is an 8, so you can put 8, 8 like this, okay? All right, so 8 times 8 is 4. So this is where you do not have to look at anything on this side because as you notice here, because I know this is a Y, this has to be an 8. We might as well guess and check this column, okay? If this column doesn't work, that means the whole thing just will not work. So 8 times 8 is 4, 1 times 1 is 1. And as you see here, it doesn't work, okay? And now we go to Z equals to 2. X2 times 18. 6, so 6, 6, okay? So you see that this is how fast you can be. And then what you do is 8 times 6 is 8. 1 times 2 is 2. Doesn't work, okay? So I know AMC doesn't really give you enough time to, think a lot about these questions. But if you do this very fast, it shouldn't take too long to finish off the question, okay? Even if you spend like maybe half a minute on per one, you should be able to get it in like 5 minutes, which is not too bad for a question 20, right? Okay, so I might give you guys a little bit longer on this now to see if you can guess and check the rest of this, okay? I'll also write it down. So hopefully you go faster than me. So z equals to 3 doesn't work. Yeah, so I guess you can take a screenshot of this if you want, but this should just be a bit of guessing check. All right, last chance to take a screenshot before I move on to the next page. I guess, yeah, so far nothing works. So we're getting pretty unlucky, but no problem. Just we only have a few more to go anyways. So, all right, I'll pause now for a bit more time, give you guys a chance to check the last three, and yeah, basically just get the one that you think is right. Okay, please put your answers in chat when you're done. Anyone else with an answer for this one? So it does seem like everything doesn't work up until z equals to 9. Oh, so I think I might have forgotten to do the carries. So sorry, I have to change everything. Yep. Sorry, just change everything. Those are updated numbers to the first page. If you want to take the screenshot again. Okay, and then let's move on to the next ones. This should be right. So this one, sorry, 72, 7 plus 2 plus is a 3. Okay, so 7 plus 6 is a 3. So I just got a bit caught up there. Maybe it's a good idea just to add in the digit here so that we don't have to do it in our heads. Yeah, because it's supposed to go up here. Okay, cool. Yeah, so after all of that, we finally got one that seems to work, which is good. All we have to do now is to figure out what x is, and we're done. Okay, so how to figure out what x is? X and z, and we know that z is also a 9, so we can put it up here. Okay, so maybe just we want a quick way to figure out what x is. I know that this bottom number here is around 9,000-ish. So 9,000 minus, sorry, divided by 18 is 500. Okay. So we know that x should be 5-ish. And yeah, if you just check 5, it does work. Okay. This will be a 2. Cool. Yep, everything works. All good. All right. So let's put the answer back at the top. I'll give you a chance to screenshot both pages again, just to, if you want the working out. There shouldn't be too much to avoid. You just have to be careful not to make any silly mistakes. And this next page here. Okay, so let's move on to the last question. Just really quickly. As you can see here, lots of these questions are to do with guess and check. So you just have to try to be systematic, okay? As you can see, the same kind of things do pop up in lots of these questions where you, for example, you start guessing, Z from 1 to 9, for example, okay? Sometimes you do get unlucky, but that's okay. Sometimes you get very unlucky, right? For the other question. Well, it was like, 12 times 3 was 156. But let's have a look at this one. So it says A is a 2018 digit number that has to be divisible by 9. Okay, so that just means that if you take B to be the sum of the digits, what does that also have? It also has to be divisible by 9. And then C also has to be divisible by 9. So, yeah. So they all have to be divisible by 9. Okay. So when we're guessing and checking this, you might as well just start off with the easiest one that you can think of. Like just all ones. Okay. So let's just go, A is all ones. So that means B has to be 2018. Oh, sorry, those are nines. So yeah, let's go with like all nines, sorry. Just to make it divisible by all nines. Okay, you do have to multiply this together. 18,000 162, I think. Yep. Okay, that means C is 18. Okay, so you can kind of see we already have a very, very big number and we got that C was only 18. So that does tell you there shouldn't be too many options left. Okay. All right, so just give you one more minute to try a few more numbers out and see if you can get something different for C. So something other than 18. Yeah, maybe now that you've tried a few more numbers, like it doesn't have to be anything fancy. You could just have done, I don't know, actually. You probably have to do a lot better than just, like you can literally swap any of those nines with zeros and you'd also have something similar. So yeah, there's lots of variety you could try. But after you've tried a few numbers, um, we still need to figure out what C is. Like, let's say you found a different one for like, I don't know, 9 or 27. How do you know there's not one for 36 or there's one for 45, for example? So that's why you do have to find a bound for this. Yeah. So C can't go over a certain number. Otherwise, it doesn't work. Yeah, you have to find something that sounds like that. Yeah, okay. So let's discuss now. So have a look at this number here. Yeah. So B is already like in the tens of thousands. It's not too big. Yeah. And you know you can't get any more than that because well, A is the biggest it could possibly be. So B can only be like smaller from here. Okay, so B has to be less than or equal to 18,162. That's kind of the key idea here. All right, so you actually do know what C is, right? It's only going to be this value. Only these are the only possible ones that work, okay? Reason why is just have a look at it. B, you can probably have 999, yeah? And that will get you C as 36, so that works. But you can't really get to C equals to 45, right? You definitely need at least an extra 9. But even, for this number, it's already bigger than 18,000. So that's the bound for this question, okay? We know that C can only be these 4 numbers. Now, like after this, it's okay if you just, write the answer down as, 9 plus 18 plus 27 plus 36, because you're pretty much sure that there's going to be something that works for all 4 of these cases. If you really want to check them all you have to do is, for example, for C is 18, you can, let's try B equals to 99, and then A, you can just go 11 nines and then the rest zeros, okay? Same for 27, you have B is 999, and then A, you'll have 111 nines. So you get the pattern now, right? Okay. So when you add them all up, you get 90. Yeah, that was the last question. So last question, definitely is, seems shorter than a lot of the other questions, but the ideas are a little bit tricky. You have to notice that B is very special, okay? You can't be very big. B has to be quite small, and then you can get what C is. Okay, so any questions about this paper? Yeah, so hopefully we've been through a few papers now. And yeah, as you get more practice, you should see that hopefully these questions become a bit more familiar. All right, so I want to spend the last almost half hour going through a very common idea in AMC papers, and that's something called pigeonhole principle. Okay, so maybe some of you have heard pigeonhole principle before, but we'll go through the definitions again and a few questions involving it. So let's have a look. Okay. The pigeonhole principle, it does stand for something called PHP. So PHP. Okay, what does it say? Well, I'll write down the full, statement first, and then we'll kind of discuss it. Okay. So you have if n plus 1 pigeons. So you basically have one more pigeon than you have pigeonholes. Okay. So what that means is at least one pigeonhole has at least 2 pigeons. Okay. I know there's a lot of at least. The reason why is kind of the wording is a little bit strange. Yeah. So for example, let's just go with the case where there's 7 pigeons and 6 pigeonholes. Okay. So maybe you could, just rearrange it like 1, 1, 1, 1, 1, 2. So there's just 2 in 1 pigeonhole. So this then works. There's 1 pigeonhole that has 2 pigeons. But for example, you could have like 0, 0, 0, 0, 0, 7, right? You have all pigeons in the same hole. And that's kind of why you need the at least 1 pigeonhole has at least 2 pigeons, because there's some cases where it could be like, for example, 0, 0, 0, 2, 2, 3. So you just see here, there's more than 1 pigeonhole with 2 or more pigeons. And then for this case, 1 pigeonhole has more than 2 pigeons. So yeah, don't really worry too much about the wording though, because usually we do just write, then 1 pigeonhole has at least 2 pigeons. People usually understand what we mean, right? It's just that here I'm just writing it in more detail, okay? Just as a bit of a definition. Okay, so we can prove this. You might be thinking right now, well, it's obvious, right? Because you just go and put 1 in each hole, and then there's kind of 1 left over, and then you have to put it in another hole. So, yep, that proof works. But I'll kind of practice something we looked at last week, okay? So if you remember the contrapositive proof, go back to your notes if you don't remember it. So what does the contrapositive mean? So remember, you have to kind of reverse the statement and put kind of knots in front of both of them, right? So, okay, what is the knot of the second part of the statement? So the second part of the statement says at least 1 pigeonhole has 2 or more pigeons. So the knot of that statement just means if all n pigeonholes have 1 pigeon only, right? Or at most 1 pigeon. I'll give you a moment to think about that, yeah? Is that the opposite of this statement? Think about it. So this statement says at least 1 pigeonhole has 2 or more pigeons. So something like 2, 0, 0, 0, 1, 1, 1, 2. But the opposite of that statement means that you can't have any 2s. Okay, I can't have any 2s or more, which means that all of my numbers have to be 1 or less. So yeah, it does work. Yeah, all pigeon holes have at most 1 pigeon. Then now you have to look at the first part of the statement and do the knot of that. Yeah, so that works, right? Because if all n pigeonholes have at most 1 pigeon, then there are at most n pigeons. And as you can see here, n pigeons is not n plus 1, right? It's less. So that's how you finish the proof off, okay? Or if I kind of write, I'll write it like this. So here I just wrote kind of the contrapositive statement. So remember, it's the A goes to B. The contrapositive is not B goes to not A. Yes, so I just reverse the statements and flip the order around. But we can prove it instantly because I know that the total number of pigeons has to be less than or equal to n. But here, the question says, then there are not n plus 1. So yeah, that works. So any questions about the proof? You can just ask me in chat if you have any questions at all. Okay. But yeah, the most important thing is you understand the statement because we'll use it in a few questions now. Cool beans. Okay. So I'll give you maybe 2 examples now. There's 2 practice questions. So first one is a little bit strange. I'm going to say that you want to pick 5 points in an equilateral triangle with side length 2. And what we're going to say is prove that 2 of the points are at most 1 unit apart. Okay, so how do we prove this? So you have an equilateral triangle and 5 points, and these 2, like you just pick 2 of those points, and they have to be at most 1 unit apart. So of course, like you can't just pick these 2 because that will be more, but the question asking there has to be a pair. Yeah. So think about pigeonhole principle. The pigeons are fairly obvious. That's just going to be the points. Okay, I have 5 points. But to use the pigeonhole principle, I would ideally like 4 pigeonholes. But what are my pigeonholes? That's the question. Yeah. So what are the 4 pigeonholes? Okay, have a think about that for a bit. So what are my 4 pigeonholes? Yeah, so to use pigeonhole principle, you need that kind of the 4 pigeonholes. Each pigeonhole should hopefully become kind of a region where the distance between 2 points is 1 unit apart, or at most 1 unit apart, right? Because if you have 4 separate regions that have something like that, and then that means 2 points go in the same region, and that's that's what you might be able to prove, right? So I think maybe it might be a little bit easier if I draw in the construction for this one. Okay. Okay. So I drew some lines in the triangle. Do we see how to prove this now? I have four regions. Yeah. Yeah. Hopefully there's some kind of realization coming along. I just drew four equilateral triangles of side length one, right? And by pigeonhole principle, I have to have 2 points in one triangle. I know it could be on the boundaries, but even if it's on the boundaries, it's still 1 unit apart. Okay. Um, because you can draw the circle. Um, this is one, so yeah, it's all one unit apart. Okay. So that's how you prove it. So by pigeonhole principle, 2 points must lie in the same region. So the small region, and those 2 points are almost 1 unit apart. Okay. So if I just draw some random points, yeah, like it could be very possible that 2 points in different regions are also at most 1 unit apart. But yeah, we don't need to overkill the question because we've already proven it. It's good enough. Okay. All right. So that's just an example of how you might use pigeonhole principle. All right, let's have a look at another question now. This might be something a little bit more commonly seen before. So this question goes like this. There's n people and some of them are friends. Yeah, and we're assuming that like if person A is a friend with person B, it also is mutual. Okay. There's no one directions in this question. So prove that two of these people have the same number of friends. Okay. So we're also using pigeonhole principle for this. Keep that in mind. Okay, so copy down the question and have a think about this one. Okay, so you always keep in mind what are the pigeons and what are the pigeonholes. This time, I will say that the N people, it's not a pigeonhole or a pigeon. Okay. Well, actually, I think yeah, and you can keep it as pigeons. Okay, so the N people are the pigeons, but what are your pigeonholes? Should have something to do with the number of friends. Okay. Okay, so the number of friends is your pigeonholes, right? So you probably want to list out what is all your possible number of different number of friends. So you could have no friends in the group. You could have one. You could have two. What's the maximum number? So like, let's say you're friends with everyone. It's up to n minus one, right? So you can't be, friends with yourself, but if you go every other person. Okay, so these are your pigeonholes. Can you count how many pigeonholes there are? And hopefully it's just going to be one less than the number of people. Well, no, it's not, right? There's still n. So we have to think a little bit harder this time. So the question is, can you have everything? Can you have a guy with 0 friends? Can you have a guy with 1 friend, 2 friends, and all the way up to n minus 1 friends? Okay, I want you guys to just pop it into chat if you notice something fishy. Anybody notice anything strange? Okay, so I'll give you a hint. Is it possible that within the same group, one person has 0 friends and one person has n minus 1 friends at the same time? Yes or no? Alan, what do you think? Is it possible to have somebody with 0 friends and somebody with n-1 at the same time? You there, Alan? Yes. Well, maybe let's have a think about it, right? So one person has 0 friends. That means that, you know, there's nobody in the group is a friend with that person. But the n-1, that basically means that, let's say that this guy was the n-1, but that means this guy is actually friends with absolutely everyone in the group. So can you kind of see that having 0 friends, having n-1, it's impossible to have both, okay? Because if you have n-1, it means that everybody in the group has to have at least 1 friend, because they have to be friend of the popular guy, yeah, the one with n-1 friends. Yeah, so this question was a little bit trickier. Uh, even if you use pigeonhole principle, it was not enough. You still had to think about this strategy here. Okay. All right, let's write the proof down in a few lines just to finish off the question. So your number of friends can go from 0, 1 to n-1. Okay, so these are your pigeonholes. However, if a person has 0 friends in the group, no one else can have n-1, right? So therefore, there's actually, instead of n pigeonholes, there's only going to be n-1 pigeonholes, because no matter how you look at it, one of these 2 pigeonholes you have to kind of get rid of, right? So let's use pigeonhole principle now. 2 people have the same number of friends, okay? Yep, so I have n-1 pigeonholes and n people, yeah? So that means 2 people have to fit in the same pigeonhole, which means that 2 people must have the same number of friends, okay? Yeah, it is a little bit confusing sometimes, going between, pigeonholes, pigeons, and then, your things. So you do have to think about it pretty carefully, okay? But this is kind of called, you can call like handshaking lemma or something like that. I think there's like a kind of a same question. Instead of people, it's just like there's n people at a party and some people handshake. So prove that 2 people have handshaken the same number of people. Yeah. Okay. Yeah. So that was just a few questions on pigeonhole principle. Okay. I guess next week we'll move on to another booklet. Okay. And then we might try a few more pigeonhole principle questions. All right. Yeah. So we probably might not get to the booklet, the AMC, and the next AMC booklet next week. So I guess have a look at it if you have time, just the last 10 questions. If not, that's okay as well. We'll probably go through it in 2 weeks. Okay. Yep, so remember to get everything down before you go. And thanks for tuning in. I'll see you guys next time. Thank you. See ya. Bye, Isabella.